Okay, let's see a summary of the SN2 and the E2 reaction because these compete with each other. Both rely upon a reactive anion. And so sometimes when you look at a reaction, you may say, oh, I don't know what the anion does. It could do an SN2 E2. How am I supposed to know? Well, let's look at this table. So here's our anion. And this anion is going to react with either a methyl halide. It could react with a primary halide. Let's see an example of a primary halide where the halogen is attached to a carbon that's attached to another carbon. It could be secondary. That would be a secondary halide. The halide is attached to a carbon with two other carbon groups. And then, of course, there are tertiary halides. And T-butyl is the most common. Let's mix it up and go chlorine there. Okay, so that's a tertiary halide. So what if you have one of our great nucleophiles? So that includes azide. I'm not going to draw the counter ions, but azide, cyanide, sulfide. These great anions, if you have a methyl halide, you always do an SN2. Primary halide, you're going to do an SN2. Secondary halide, SN2. Tertiary halide, I don't care how good your nucleophile is, the great nucleophiles will not do anything to a tertiary halide. The halide is too hindered at that carbon for the nucleophile to attack it. And the fact is, these great nucleophiles are weak bases. So the idea of doing an E2 is off the table. Now let's look at our good nucleophiles from the SN2 reaction. This included things like hydroxide, alkoxides, amines, which we haven't talked about too much, but they are basic. And then these other bases that we'll hit later in the course, things like enolates and acetylides. What do these do as reactive anions with the methyl group? Well, with methyl, as it turns out, they also do an SN2. With a primary halide, they tend to do an SN2. The change comes when you have a secondary halide. These merely good nucleophiles, which are they all happen to be pretty strong bases. Once you make the halide too hindered, the nucleophilicity loses to the basicity. It's kind of a Jekyll-Hyde thing. And the basic side says, forget about it. I'm not going to attack that thing. I'm just going to pluck off a beta hydrogen. And when you start talking about plucking off beta hydrogens, you are in the realm of the E2 reaction. Tertiary halides, again, whereas the great nucleophiles were weak bases, the merely good nucleophiles are strong bases, and they have the reactivity to do an E2 also on a tertiary halide. So this is what happens with different reactive anions as we put this table together, as we react them with different halides. And really what we're doing as we move across this table is we are increasing steric hindrance. Oops, sterics. And as you can see, the E2 reaction, when you have a lot of steric hindrance, it's easier to pluck off a beta hydrogen than attack an electrophilic carbon. So this is a table to help you organize your thoughts. What does each anion do in the presence of different alkyl halides?